So we're using substitution to evaluate algebraic expressions. So basically what this section is it gives you values for the variables, and you substitute those variables into the equation to simplify it. But one thing that I always suggest is that you use parentheses when you're going to substitute and whatever the number is for the variable. So we have the expression x squared plus 3x, and it's asking us to evaluate that for x is equal to 4. So basically what that means is that you're going to substitute x with 4.
That's a 4 or a negative 4?
Negative 4, yes. So like I did here, I put negative 4 inside of parentheses. This is how I recommend that you take it back to the equation, to the expression. So in the place of x, we're going to put negative 4. Put the squared back there. Bring down a 3, and in the place of x, we're going to put negative 4. So this is what I mean when I say use parentheses to substitute the number for the variable. We have negative 4 inside of parentheses here, being raised to the second power. What do we get? Right, positive 16. And what about here? Okay, so then, our final answer is a positive 4 for that. So when x is equal to negative 4, our value is positive 4. Okay, so we have the expression a squared plus 3ab minus 2a minus 4. And we want to substitute a with 1/2 and b with 1/3. So again, I recommend that you put your whatever you're substituting in parentheses like that. So I would take 1/2 and substitute it in the place of a. So every place where a is, we substitute it with 1/2, and b is 1/3. And then we have 2a, so 2 times 1/2 minus 4. All right, so how should we go about solving this problem? So what does it become? If we do it like this, 1 squared over 2 squared, we take that power and apply it to both the numerator and denominator. That gives us what? 2? 1. 1 squared.
So that's
1 times 1.
yeah.
So that so 1/4, right? Where at? The power here that we're on? Whenever we have a fraction that's being raised to a power, that power will go to both the numerator and the denominator. So keep in mind that the power means that we're taking the base and multiplying it by itself that many times. So the base is 1. So we're multiplying it by itself 2 times. The base for the bottom is 2. So that means with the power of 2, we multiply 2 by itself. So that's where we get 1/4 from there. And let's just rewrite everything. All right, let's look at these. We've already taken care of this one here. Looking at the next one, because multiplication would be the next thing that we do, and the first multiplication that we run into is this one here. See anything that we can do with that? So this is multiplication between those 3 there. Anything we can do before we actually do the multiplication? Okay, yeah. We can turn this one into a fraction, and now what? Well, we don't want to do that yet. We want to try to simplify it first. Simplify this whole multiplication here. Right. So from numerator to denominator, we can cancel as long as there's multiplication in between the factors. So 3 goes into 3. So we're left with 1 over 1 times 1/2, 1 over 1. So the 1 over 1s we don't need, because when we multiply everything top to top, 1 times 1 times 1 still gives us 1. And then 1 times 2 times 1 gives us 2. So we get 1/2 out of that. Let's bring down the minus. Okay, what about the next term? So we can put a 1 under this, and so what are we left with? Right, we left just 1. So all right. So now we need a common denominator. What would it be? It can never be smaller than the largest number.
Like times the 2.
Oh,
The
okay.
other
Oh,
says 2.
okay. Right. So 4 is our LCD, right? Because 2 can divide into 4. So the LCD is 4, and now we can take that LCD and make everything else in terms of that LCD. First one already has a 4 denominator. Right, so we multiply this one by 2 to get the 4 in the denominator. And right now, this one is just like saying 1 over 1 and 4 over 1. So we do minus and then multiply it by what?
Sorry, I'm multiplying.
Because we want 4.
Oh, we want to make all of them.
The denominator 4.
So then times 4.
Right. So 4 over 4. And then minus 4 over 1. And we multiply this one by what? All right. So now we have everything with our LCD, and we just add and subtract the tops up, from left to right. So 1 plus 1. Let's just take it like this here. 1 plus 1 is going to give us 3 over 4. And then if we look at these two, negative 4 minus 16 gives us what? Negative 20. So negative 20 over 4 for this part here. And then let's go and combine this. What's our final answer?
Negative 17 over 4.
Right. Okay. Okay. So on page 113, you have formulas for perimeter and area for the different type of figures.
You said 113.
On, yeah, page 113. There's formulas. As you can see, you have formula for a parallelogram, for perimeter and the area. Then you have one for the rectangle, the square, trapezoid, and so on. So So this question asks us to find the area of a circle if the radius is 5 centimeters. So what is the area of a circle formula? So what is that formula? From page 1, right, pi times r squared. So in that formula, the r is the radius. Hmm?
That's what you're asking us to do.
Uh,
Five, the second column.
oh yeah, pi is 3.14. Now, radius, if you look at the figure in here, the radius is half of the circle. So if we are looking at the circle here, and then the center, this would be r. The we also have a diameter. Diameter is the full portion. So diameter in for this case would be 2 times r. So if you were given diameter here instead of radius, then you will have to consider that. So since we're given radius in this one, we can go and substitute in what we have for the in the formula. So r radius is 5 centimeters. So when we substitute in our radius, again, we put it inside of parentheses. And we have the squared. All right, what does that tell us? You know, when we make the calculation, we're going to keep pi like it is. Yeah, but let's keep pi as just a symbol.
Okay.
Mm-hmm. Right. So 25, but cm also has to be squared because of the square here. So 25 cm squared. So it's just like taking that square to both the 5 and the cm and put in our pi. So 25 cm pi, or vice versa.
Okay, so now I have a question.
Mm-hmm.
So why are we leaving pi the way it is? Why aren't we doing a 3.4?
Well, if you have to, then you know you will. Problems will tell you specifically. Let's do it anyway.
Oh, so they do, okay, I'm just wondering, because
Mm-hmm.
I'll do it all and then I'll be wrong, but the equation would tell me now to do that.
Yeah, yeah, yeah. But let's do it anyway.
Not to do it. Right, help me, friend. Okay, thank you.
Well, in this one, it didn't tell you not to do it.
Right,
So
where did it,
you will have if it gives you the value for pi, like pi, we're going to use 3.14. So if we take 25 cm and then multiply it by 3.14. So what did we get? 7.
78.5.
So 78.5 cm squared when we multiply 25 times 3.14. Hmm. Yeah, yeah, yeah. As long as you know if a problem gives you or asks you to use the value of 3.14 for pi, then you know how to go back and substitute it in. Mm-hmm.
Where I was a little confused.
For the value,
Yeah,
for.
but to find the area of the circle if the radius is 5 cm.
Mm-hmm.
They told us to look at the formulas and they told us that 3 pi is 3.14. So
Mm-hmm.
I'm just saying, like, what would the question look like? Just find the circle, what's up there without the pi?
Um,
I don't know,
if
but I'm just, you don't have, you can just tell me. I mean, will it
if
say
you
include pi?
yeah, you'll have the value for pi.
Okay.
So it'll say something like pi, use 3.14 for pi.
Okay.
And you know, and in that case, you're gonna have to go back and substitute it. So So this one is asking to find the area of a triangle with a base of 9 and a altitude of 20 inches. First thing we have to know is the formula for a triangle. Okay. It's 1 over 2. Sometimes it could be represented as the base times the height, but means the same thing. The height would be the altitude and the base would be the bottom of it. Okay, so going in and substituting what we have. The altitude and keep in mind that it's in inches, and then we have the base in 9 inches. So if we're multiplying, if we're going from left to right, that is, we're taking these two. So that means we can put this under one under that one. And then do what? How? Right, 2 goes into itself one time and goes into 20. So now this looks like 1 over 1, which we don't need anymore because we don't have any other fractions. So it becomes 10 inches times 9 inches. So what is the area equal to? Inches? What about the inches?
Yeah, no, that's it, not the inches. Oh, no, we don't, that's not part of it.
One thing times itself gives us what power? Second power.
Oh, see, I'm gonna lose on that one.
So inches squared. 9.
It's spot differently. It's about like 20 times 9 and then divide that by 2.
Yeah, you could do that. The reason why we start to simplify before we do the multiplication is because the numbers are going to start to become more larger, more complicated if you do it that way, and then simplify in the end. But certainly, that's one way that you can do it. Right here, because we have inches here times this inches. It's just like writing this as 10 times 9 and then inches times this inches.
So would that apply inches and centimeters, or would that not happen?
Well, you wouldn't have two different measures. So if you do, you will have to convert it into, but you won't. So anything times itself, it doesn't matter what it is. If it's an x times an x, you get x squared. If it's a centimeters times centimeters, you get centimeters squared. What about this here? Right. Okay.
I forgot about inches, so I don't know.
hmm
90 and I moved on.
And yeah, if you have physics coming up, I know some classes have physics. Some majors have physics. It's going to be really important that you know the measures, how to use the measures. And all right, any other questions? Let's take a 20-minute break.
This one. Can you help me with that?
I'm ready to go.
3x second minus 7x plus 9, and then you've got x equals minus 4. It was on your test, and it was the one I had wrong, and none of the answers you had I got. So I need your help, because that was...
And what, well, let me